So today's lab is about synthesizing or producing aspirin, correct? So we will be working on getting aspirin. Now, aspirin is really, if you look at the whole thing, it's an ester. It's what? An ester. Esters are made of reaction of the carboxylic acid with alcohol. Now, this will act as an alcohol here, phenol or alcohol, and this will react as acid. So we will have salicylic acid. The name of salicylic acid, if you look at this is first priority. Will take carboxylic group will take first priority over the hydroxy group, correct? We learned that in the lecture. So this is benzoic acid. So this is benzoic acid. And this is number 1 here, correct? This is number 1. If you look on number 1, this is carboxylic acid 1, this is 2, this is 3. So let me just write it again. Different color. This is 1, this is 2, this is 3. Okay, guys, so this is benzoic acid, and this is 3-hydroxy benzoic acid. Okay, if you can, this is what? This is 3-hydroxy benzoic acid. If you take carboxylic acid as 1. But this is called, the name is salicylic acid, whether it's common name or IUPAC name. This is salicylic acid. The name of it is salicylic acid. We go by salicylic acid. But we know that's a benzoic acid with hydroxy group. The anhydride, this acetic acid anhydride, you have 2 molecules of acetic acid, you pop out of them 1 H2O to get this anhydride. So you have 2 acetic acid, correct? The other one is here. So then you take H2O out of these here, 2 acids here. Then you get what? Acetic acid anhydride. Anhydride means without H2O. So 2 molecules of acetic acid, you pop out H2O, you get acetic acid anhydride. Correct? So you let them react together. This is an acid, remember, this is an alcohol. You get an ester out of this, correct? An ester of this is salicylic acid, and this one here is acetyl group. Acetyl group. So the name of this now will be acetyl salicylic acid. So the whole thing is salicylic acid. As you can see, the whole thing is salicylic acid. Then you get from the acid this acetyl group, and this is esterification. That's an ester. And then we'll pop the second acetic acid will come as a byproduct. So this acetyl salicylic acid called aspirin. The commercial name of it called what? Called aspirin. But the real name is acetyl salicylic acid. So today in the experiment, we'll have the opportunity to synthesize to make aspirin. You'll have the opportunity to make what? Aspirin. It's a very good medicine to cool down the brain if you have headache or you have fever or whatever. Aspirin is good for these purposes. As well as aspirin is very important to open up the veins that are going to the heart. Anyone has heart problem and had blockage in the vein will be recommended by his physician or her physician that he or she has to take daily amount of aspirin. So the good thing about aspirin is opening up any blockage in the veins that's going to the heart. Correct? So now this reaction, what type of reaction is this? This is esterification. We make an ester. And this ester is really aspirin coming from the acid and the alcohol. In this case, alcohol. So that's esterification. So the reaction is called ester, make esterification. Make an ester. You make an ester. An ester is made from alcohol plus an acid, carboxylic acid, of course. Alcohol here in this case, phenol. So that's the whole thing about the chemical reaction. Now, the logistic is very simple. It's not really difficult. We can look at the logistics here by taking this one out. So just bear with me a little bit. I want to get a new window. Just show you about the logistics here. And then you can read the details of the experiment and follow the details. I'm giving you the headlines of the experiment. So what we have to do in this experiment here, you take a 400 large beaker, about 3/4, more than half or maybe 3/4 will be good. So this is water bath. Water bath. Then you put this one here on the hot plate. Okay, that's the dial of the heat. That's the temperature dial. Don't worry about that's the stirrer. Take it off. So that's the stirrer off. That's the heater. We are using the heater, correct? So in this is a hot plate. The first thing you'll start doing nothing. Turn on this hot plate. It takes time for the tap water to boil. It takes time. So you boil this one here, and then meantime you will have your components there. You will have your salicylic acid, correct? 2.5 gram of salicylic acid, 2.5 gram of salicylic acid, and then you weigh this one here, 2.5 grams. You will add to it, 7 maybe, or yeah, 7 drops of sulfuric acid, and you will add to it is, let me just double check for you the amount of acetic anhydride. I think it's about, it is, let me just look at the, it is 2.5 gram of salicylic acid is solid, and then you will add to it your 4 ml, I said 4 ml of acetic anhydride, and about 7 drops of, so then this one here plus here plus 7, we said 7 drops, and then we will have 4 mLs of acetic anhydride. So let me just take this one out. So you will have acetic acid 2.5 grams, 5 grams of H2SO4, and 4 mLs of acetic acid. So then you'll put all this content here inside Almayer flask. Okay, so you have here, let me just, so you'll have your Almayer flask here. And the tab are here for heating here. So all those components here, this one here, 4 mL of acetic acid anhydride, 5 grams, 2.5 grams of salicylic acid, and 7 drops of, all those are here. Okay? You will wait until all the salicylic acid solid is dissolved. Remember, that's the only thing is solid. This one here is solid. Acetic acid anhydride, this is liquid. And sulfuric acid is a liquid. Now, you will do all your experiment inside the hood. You are not allowed to put it here because if you get something acetic acid anhydride, the smell of it is very, very nasty, very nasty. And the sulfuric acid should not leave the hood. That's highly concentrated acid. So it can cause first-degree burn, so very dangerous. So it has to be kept inside the hood. The only thing is really harmless is salicylic acid, has no smell and it has white crystals. When you put this one here in the boiling bath here, you keep an eye on all the crystals, these crystals here, the solid here, dissolve. That will tell you that the reaction is ongoing and the reaction is progressing. That's a very good sign. Now what you will do here, you will take it and you cool it in. Meantime, you will have a metal plate or a metal container here. You put in it ice. Ice is here. You put it inside it ice and some tap water for cooling. So you take this Almayer and then put it inside the ice. When you will sit for a couple of minutes, 10 minutes, and then you will add to it from the ice you have it, maybe 4 mL at the beginning, and then you'll add more, about maybe 10 mL or 15 mL. It does not really matter. We're adding this icy H2O to help the crystals to what? To grow quickly and precipitate quickly. That's all the whole idea. We don't just, it will take longer time for aspirin, acetylsalicylic acid to be produced. Correct, guys? So when you are done with this, then you will have to do a vacuum, correct? A vacuum filtration. A vacuum filtration will look like this. You have a Buchner funnel, special funnel with holes inside it, correct? It has holes inside. This Buchner funnel will hook it to the water pump. You can do it on your bench, no problem. But the main thing you have to have control on the cover, otherwise it will jump all over the place, and you might have to take your digital items out of the bench, secure there's no cover will come into your digital items. So now we have these crystals. We have to filter it. But before we have to use this vacuum filtration, you have to have filter paper. Filter paper are here. You have to weigh it. And before weighing it, write the name of your group. Suppose you are 2 people are working, write the name of the 2 people are working. 3 people are working, write 3 names of the people are working. We'll keep it over 1 week to dry because it takes longer time to dry. For aspirin, for acetylsalicylic acid, takes longer time to dry. So you'll take it And filter paper, the names of the people in the filter paper. Then you put the filter paper inside Bushnell funnel. And the Bushnell funnel is a funnel made of ceramic porcelain with holes inside. So it can hold the pressure of the vacuum. You cannot do it with the small tiny funnel. It will collapse. This is a very heavy. Can I take this one out? I want to show you how this funnel looks like. Can I take this one out? Okay, let's take this one out and look at the here it is. This is the Bushnell funnel. That's the chemical reaction. As I said, from this, let me just repeat myself here. This is 2.5. Oops, sorry. 2.5 grams of this, correct? The sulfuric acid, that's the catalyst. 7 drops. And this one here, we say 14 mils, correct? 10 to 14 mils. That's excess. We have to take it 14 mils. We will destroy it later on. So then you will produce this one here, correct? Let me just correct myself if that's correct. It is 2.5 grams salicylic acid and 4 mils of acetic acid. Not 14, 4 mils. So let's go back and look at the, this is not 14, but 4 mils of acetic acid anhydride. So those are the amount here you'll add, and that's what you will get. Now the 4 mils, there will be excess of them. There will be excess of this. We have to destroy the excess of the acetic anhydride. After we have the whole crystals there, you'll add some icy tabor slowly. That will destroy the acetic anhydride, excess of it, correct? So, and then you will go for the Bushnell funnel, which is here. Let me show you here. This is called the Bushnell funnel. This is Bushnell funnel. It's made of hard ceramic or porcelain with hole inside it. Too many holes. You will weigh a filter paper there with the names underneath. First write the names and then weigh after you write the names of your group. Then you put the filter paper here in the top and you filtrate whatever is coming out of this Erlenmeyer. Remember the Erlenmeyer here has acetic acid and anhydride and salicylic acid and sulfuric acid. So you dump the whole thing, you filter here, they call it vacuum filtration. This is vacuum filtration. This goes to the vacuum, and then the liquid will come here, and your aspirin is here. Your aspirin will be inside your filter paper. And underneath the filter paper, the names of your group, because we have to keep it until next week. Without knowing the name of the group, we will be confused. Where is my aspirin? So therefore, we'll have the name of your group underneath. So you take it out, and then you just will do next week. You test for the extra acetic anhydride if it's still there. We'll test all the reactants if they are still there or they are already reacted fully. We'll do iron trichloride test for the phenol, for alcohol. Is all the salicylic acid reacted? We'll know this. And then we'll add inside the process H2O, the ICH2O, to destroy the excess of acetic anhydride. So we'll test for both to make sure that both reactants are really out of our reach, so we don't have them inside our final product. We need just the acetyl salicylic acid. We need just the aspirin. We don't need the reactant to be there with the aspirin itself. Correct, guys? So in order to do this test, we'll do it next week, because your aspirin has to be what? Has to be dry, and it will dry at least overnight, or over the whole week next week. Correct, guys? So any question you have? Any question you have, guys? That's the whole process here. When you have everything here, then you have your filter. Put your filter in inside watch glass and put it there at the last cabinet there. Remember, your filter paper, don't wait first. You have to write the name of the people in your group. And then you wait, and then you use it inside this Bushnell funnel. Any questions so far? Next week when we come, we will test. We'll test the alcohol, this phenol, with iron chloride. If we have still phenol there, alcohol, with iron chloride will be purple. Iron chloride, yellow solution. And when you add to it small tiny your crude aspirin, if you have still phenol, you put some of your aspirin, a little bit, just after weighing it, of course, you have to weigh. Don't take anything. After we are coming from the whole thing next week, you will weigh your aspirin. You have to know the mass of it, because you have to calculate what? You have to calculate the percentage yield. I'll show you in a minute how you do that. So then you will test it for the phenol, the reactants, the salicylic acid, with iron chloride. If you have phenol still there as reactant, then it will give you purple color. If there's no purple color, then all the phenol is reacted. And then we'll destroy our excess, the 4 ml of acetic acid anhydride. When you add the ice H2O to it, whatever we have of our acetic anhydride excess will be taken care of, will be converted into acetic acid, which will be sucked through the vacuum filtration. So now, let's go and look at the calculation here. The actual yield is whatever is when you come back next week. When you come back next week, you will weigh your what? You will weigh your aspirin. Weighing your aspirin, that will give you the actual yield. That's what you obtained after mixing salicylic acid with acetic acid anhydride. That's what you got, right? It's dry. Now this is actual yield. The theoretical yield is based on the fact that 1 mole of salicylic acid, 1 mole, plus 1 mole of acetic anhydride will give you 1 mole of aspirin. So that's how we calculate the theoretical yield of aspirin. So what you will do, that's your mass of salicylic acid you started with. We said what? Around 2.50 grams. Then you divide it by the molar mass of salicylic acid. Gram salicylic acid with the gram salicylic acid cancel out the grams here. And then the mole of salicylic acid will come here. 1 mole of aspirin to 1 mole of salicylic acid. See here this relationship, 1 to 1 mole. So mole salicylic acid cancels with mole salicylic acid. Then the molar mass of aspirin, multiplied by the molar mass of aspirin, this is the molar mass of aspirin, 180 grams per mole aspirin. Aspirin cancels out. Your answer will be in grams. That will be your theoretical yield based on the whatever amount you have put. theoretically 2 grams, 2.50 grams. Okay, guys? And then with the percentage yield, we can look at the whole thing. Usually, the aspirin experiment is straightforward. You can get about 80 to 90% yield. So usually this is the percentage yield can be 80 to 90%. It's straightforward reaction and it's very quick, but then the dryness takes time. Once it's dry, you keep it overnight, or you keep it for 1 week, and the next week you can come and calculate. I think I'll stop here. If you have any question, let me know. Any question, guys? So, okay, I'll stop here. A very straightforward experiment. And then next week when you come, I'll explain how to use the melting points. The melting points, how we do melting points and how we test the phenol next week when our aspirin is done. Let's